Hello everyone. This is an overview day, second day of this section. The first day we covered factoring, so this is just going to be mostly a overview. To start, I'd actually like you to try the following warm-up question. Ask yourself, how did we multiply these? We also call that expanding the expression. It's just multiplying. You have to do double distribution. And then this is what we looked at in the first day. How do we factor it? So pause the video now, see what you recalled from the first day that we did it, because we were able to do ones like number 2. And then don't forget that you have to also be able to multiply. These two things are interrelated because factoring is really kind of a division, and then this is just multiplication. So pause video now for maybe a minute, unpause it once you've given it a chance and you want to see where you were at. So pause video now. Okay, here we go. Here's the first one. You'd have to multiply it out, double distribution. You distribute the x first. X times x is x squared. X times 1 is 1x. Then you distribute the 3. 3 times x is 3x. 3 times 1 is 3. Combine your like terms, and you'd have x squared plus 4x plus 3. If you use tiles, you'd see if you have x plus 3 and x plus 1, you get x squared, 4 x's, and 3 little 1's. In factoring, you're doing the opposite. I tell you all the pieces laid out, and I want to know what the dimensions are. Well, look at this one over here. Why is this number a 3? It's a 3 because it's the multiplication of 3 and 1. Why is this a 4? Because it's the addition of 3 and 1. So when I'm factoring, I want to find two numbers that multiply to make the last term and add up to make the middle term, so long as there's a number 1 out front. But all of ours for this unit will be for now. So what are the numbers that multiply to make a positive 6 and add up to be a 5? If it multiplies to be a positive 6, they either need to both be negative or both be positive, but since I see that they add up to be a positive 5, I know they both need to be positive. So the only options are 1 and 6, but those add up to be 7, so it can't be that. Has to be 2 and 3, and those add up to be 5. So my factors are x plus 3 and x plus 2. If you had tiles and you did x plus 3 by x plus 2, you'd see you'd have 1x squared, 5 x's, and 6 little 1's. So that's what we worked on the first day that we tried this. We are going to review that topic. We're going to review factoring, just practice some more of them. The steps when you are factoring are as follows. The first step is you should always look to see if you can simplify. Can you do what we call greatest common factor factoring? Is there anything you can divide out of everything to make the problem simpler? If there isn't, then you're on to step 2, and that's where you're going to try to find two numbers that multiply to make the last term, add up to make the middle term. So here's an example. 1x squared minus 11x minus 12. I can't do any greatest common factor factoring because they don't all have any number in common, and they don't all have x's to divide out anything out. So step 1's done. Now I need to try to find two numbers that multiply to make a negative 12, add up to be a negative 11. So here are some clues. I know, so here's my factors. I know it's going to be x and x. I know it multiplies to make a negative. The only way you can multiply to make a negative is if one of the terms is positive and one of the terms is negative. So I know there's a positive and a negative. And I know that they need to add up to be a negative 11. So the bigger number has to be negative. So when I'm listing all the factors that multiply to make negative 12, well, it could be negative 6 and 2. It could be negative 4 and 3. Or it could be negative 12 and 1. And recall, I need the bigger number to be negative because I have to add up to be negative. So there has to be more negatives than positives. Negative 6 and 2, that adds up to be negative 4. It can't be that. Negative 4 and 3, that adds up to be negative 1. Can't be that. It has to be the minus 12 and the positive 1. If you multiplied this out, let's check. That's what this little table is for over here. X plus 1. It doesn't matter where you place. I could have put x plus 1 over here. X minus 12. When I multiply it all out, x times x is x squared. X times 1 is 1x. Negative 12x. Negative 12 times positive 1 is negative 12. If you combine your like terms, I get x squared. Negative 12x plus 1 is minus 11x minus 12. Voila. I have the original problem, so it checks out. How do I check? I multiply it through. That's why factoring is our version of division. So there's the answers. That's what it would be in factored form. It's very similar to what you did with numbers actually in middle school. So if you think about if they asked you to factor numbers in middle school, let's say they might say factor 6. Well, if you factor and break 6 down, it'd be 2 times 3. And how do you check? Well, because 2 times 3 equals 6. So just the way that numbers break down into factors, we can also see that expressions eventually will be a version of an equation. They also break down into factors. So that's what we're kind of looking at there. Let's try a few more. So This one, there's a negative out front, and actually I can divide everything out by a negative, so I have a positive x squared. So if there's ever a negative number in front of your quadratic expression, divide that negative 1 out. We want a positive x squared. So if I divide out a negative 1, everything else will flip signs. I have x squared minus 3x minus 28. Now I can't divide anything else out, so I'm playing the game of what two numbers multiply to make negative 28 and add up to make negative 3. Again, I see it multiplies to make a negative, so I know my two factors. One of them is going to be positive and one of them is going to be negative, so I have x plus and x minus. I'm going to move this down so I get some room. I know the bigger number needs to be negative, so when I'm listing out all the factors, I've got what? Negative 28 and 1. I've got 2 and negative 14, and I think the last one's negative 7 and 4. This adds up to be negative 27. That adds up to be negative 12. Hey, that one adds up to be negative 3. There's my combo, minus 7 and plus 4. And if you wanted to, you could check. You have x plus 4, x minus 7, x times x is x squared, x times negative 7 is negative 7x, 4 times x is 4x, 4 times negative 7 is negative 28. If you add up all of your terms, you have x squared minus 3x minus 28. Then the last thing we need to do is multiply by that negative 1 that was out there. And when I multiply by the negative 1 and it distributes through, I get negative x squared plus 3x plus 28. And again, voila, that was the original problem. So my factors are x plus 4 and x minus 7. There needs to be a negative 1 out front. Last one, then I think I'll have you try. X squared minus 13x plus 40. There's nothing I can divide out. They all don't have a number in common. They don't all have an x. The first one has 2, the middle one has 1, the last one has 0, so I can't divide an x out. So now I'm on to step 2, where I'm just trying to factor. My clues are here. Well, I know that, again, it always needs to multiply to make the last term and add up to make the middle. If it multiplies to make a positive, both terms are either positive or both terms are negative, both factors. Well, it can't be both positives because two positive numbers are never going to add up to be a negative, so it has to be the case that both of these are minuses. Now I go through all of the, the factors of 40 where both of them need to be negative. So what? Negative 1, negative 40, negative 2, negative 20. You can do this in your head and start to get pretty quick with it. Negative 4, negative 10, negative 5, negative 8, and then I think that's it. If you go and find which ones will add up to be negative 13, it's not that, it's not that, it's not that, it's that one. So x minus 5, x minus 8. Some of you might ask, could I write it as x minus 8 and x minus 5? You most certainly can. The order in which you multiply two items doesn't matter. Either one of those would be the correct answer. The order in which you write them is not important. If you want to check, you could make a little multiplication table, or you multiply it out by doing double distribution. I'm just using the table to check. But you could just multiply without the table, do double distribution. When you multiply it all out, you're going to see you get x squared minus 13x's plus 40, which was the original problem, so you factored it correctly. I'm going to have you try. I'd like you to try factoring these two. I'm going to help you with the second one. The second one has a first step you need to do. You'll notice all of the numbers are even, so you can divide out a 2 actually at first. If you divide out a 2, it'll be x squared minus 9x plus 14. Then all you need to worry about is what's going on in here when you're factoring. So there's a hint for the second one. Give these two a try. Pause the video now, come back after maybe a minute and a half, 2 minutes, and you've given it a go. So come back when you want to see what the answer is. Okay, first one, I need to multiply to make a 27 and add up to be 2, or 12. And that's going to be, oh, I don't know why I wrote it like that again. It should be x plus 9, x plus 3. X squared, 3x, 9x, 27. That'll make the correct combination. So x plus 9, x plus 3. Again, the order in which you write those does not matter. There's that hint I gave you on the second one. The factors, if it multiplies to be a positive and adds up to be a negative, you know that both of them need to be negative, and it'd be these guys, x minus 2 and x minus 7. You could use the table to check. I'll let you do that. But your answer would have been that guy right there. So, and that's about as difficult as they can get. we're going to just try ones that are going to push your thinking a little bit, but in terms of the actual skill of factoring, if you can knock out the ones that we did, trying to find numbers that multiply to make the last term, add up to make the middle, you're in a really good spot. You're going to see the vast applications of that skill in the following sections. The last part is just going to ask you to extend your knowledge a little bit, apply it in some critical thinking aspects. So consider the following scenario. It says, based on the following information, what are the possible values for b? So here's the clue. I know that the two numbers, because I'm trying to factor it, have to multiply to be a positive 12. Well, if they multiply to be a positive, that means that they're either both positive or both negative. But if I look at the middle, I see that they add up to be a negative. So that means that both of those factors need to be negative. So what are the values that b could be? Well, what numbers are both negative that multiply to be a negative, or that multiply to be a positive 12? Well, it could be x minus 1 and x minus 12 would work. If you did that, you'd have minus 1x and minus 12x's. Well, that would be minus 13x's. So one of the possibilities is x squared minus 13x plus 12. So there's one possibility. I bet you can see there's a few others. What are other ways that I could get to positive 12? Well, it could be minus 2 and minus 6. That would make minus 2x minus 6x. In total, then, it'd be x squared, but then minus 8x plus 12. So negative 1, negative 12, negative 2, negative 6. There's one more. It's going to be negative 3 and negative 4. That would also multiply to make a positive 12. And in that case, you'd have x squared minus 7x plus 12. So what are the possible values? You could have had minus 13x in the middle, minus 8x in the middle, or minus 7x in the middle. So there you go. That is it for the second day of this section of factoring. Thank you very much. Have a good day.